Okay, pretty straightforward question. They give us a function. They have some transformations they want us to do on it. There are technically four transformations. This minus sign means a vertical reflection, or reflection across the x-axis. The 2 means vertical expansion by a factor of 2. The minus 3 translates at 3 units right, and the plus 1 translates at 1 unit up. So if we have points on our original curve that look like x, y, here's what's going to happen with those. First, because these are both vertical, these will affect the y-coordinate. Our x-coordinate will be totally unchanged, and our y-coordinate will get multiplied by -2. The negative is the reflecting part, and the 2 is the vertical stretch part. Then we'll translate 3 units right. That'll increase our x-coordinates by 3. And we'll translate 1 unit up, which will increase our y-coordinates by 1. All right, so overall, this is what's going to happen to our coordinates. The x's will go up by 3, and the y-coordinates will get doubled, inverted, and then increased by 1. So let's see what that does to some of these coordinates. We'll just move all these points over and see what we get. So the original starting point for this function was -3, -2. So if we take those coordinates, take the x-coordinate and increase it by 3, easy enough. Take the y-coordinate, which is -2, multiply it by -2, that's 4, then add 1. The new point is 5. So that point maps to up here. It's not totally clear yet how this shape is going to look afterwards, but as we lay on more points, that'll improve. Next point along the path is right here, -1, 0. So if we take those coordinates, take the x-coordinate and add 3 to it. Take the y-coordinate, 0. Multiply it by -2, still 0. Add 1 to it, and we get 1. So the new point is 2, 1. There we are. Now these 2 points are connected by a straight line, so there we go. Next, we get a curve which peaks at 0, 4. I'll start up here. That point 0, 4, and again we're supposed to take the x-coordinate and add 3 to it. Then take the y-coordinate, 4, multiply it by -2, that's -8, and then add 1 to it. That gets us to -7. So this point is now 3, -7, which is down there. I won't connect the dots just yet. I want to get the next couple of points, and then I'll do it all at once. This point at the bottom of the arc is 2, 0. I'll go a little faster because I think you probably get the idea here. Take your x-coordinate, add 3. Take your y-coordinate, double it, add 1. So there's a new point, 5, 1. And finally, at the very end of this curve, we get 3, 5. So take the x-coordinate, increase it by 3. Take the y-coordinate, double it, add 1. If I'm not mistaken, that's -9. So we get 6, negative, it's off the edge of the screen, rats. I'm going to cheat and put it right there. That's like 8.7 something. Should be close enough. And now if we connect these with a polynomial looking curve, we get, there's a peak, there's our valley, and there's the end of it. So this curve is upside down, twice as tall, and it's been moved to the right and up. But the same general features of like a straight line followed by an S-bend are still there. You can plot as many or as few points as you want when you're doing this until you're confident you have enough landmarks to do a halfway accurate sketch.